that probably take her.
Hey, I am back once again with another video. And this one is going to be your midterm review practice. Now, I hope this helps you prepare for the county final. The county midterm. I have no clue what's on it. But my guess is we've covered everything that you'll see. With that being said, let's get started. Alright, here we go. Number one, write the equation of the following graph. So we have this graph here. I'm going to make it bigger real quick so you can just see where I'm about to pull these numbers from. Alright. The thing I want you to notice is this graph is written in fourths. See, it's 0.25, 0.5, so it's 1/4, 2/4, which is a half, 3/4, 75%, 4/4, which is pi. Alright, so the graph is definitely written in fourths. Okay? Just decimals instead of fractions. Now, what I gotta do is I've got to first use cosine as my trig function. So if I use cosine as my trig function, right? Remember, cosine would be high, middle, low, middle, high. Alright, or in this case, see how it starts right here? Instead of high, it's low. So this would be low, middle, high, middle, low. It's just flipped. Alright, it's reversed. Okay. So, again, here's where that cycle started right here. So that's going to be my phase shift. Alright, and then if you remember how long one cycle is, this right here is going to be my period. Alright, how long this is right here. Okay, so I'm going to make an equation off of that. So we know it's cosine. Alright, now let's look at the amplitude real quick from the midline. How high up does this go? 10. So I'm going to go negative 10. And the reason I go negative 10 is, remember, this opens down. It started here, it goes up. So negative 10 cosine. Alright, now we got to address the K value. Alright, so this is the period for cosine. Remember, it's 2 pi over k. Alright, well, we don't know what k is, but we know what the period is pi. So if I solve this real quick for k, I multiply by k on both sides. K. So that cancels. So 2 pi equals pi k. And now I'm going to divide by pi on both sides, and I get k equals 2. So 2 theta. Alright. Now notice the phase shift is 0, so I don't have a c right here. So there's our equation right there. Alright, negative 10 cosine of 2 theta. Or you could put 2x, it doesn't matter. Alright. Now for sine. Using the same graph, I'm going to treat it like it's sine. Well, if you remember, for sine starts in the middle. So middle, high, middle, low, middle, right? So this one starts at pi over 4. So that's the phase shift. Pi over 4. So that's my phase shift right there. Remember, the phase shift is where it starts. Alright, and then how wide is this? Well, again, that's 1. It starts at 0.25, it ends up at 1.25, so it's 1 pi. Alright, so I know the period is pi as well. So, guys, since it's sine, remember we just did the 2 pi over k equals pi, the period is pi. Alright. We'll run with that. So we solved this and we got k equals 2. K is 2. Alright, next. Negative c over k, where k is 2, equals the phase shift of pi over 4. Right? So now what I'm going to do is, we can cross multiply this, so you get negative 4c equals 2 pi. And then I'm going to divide by negative 4 on both sides. And I get c equals, see that right there, 2 over negative 4 is negative 1/2 over pi half. So that's c. So I have k, I have c. Alright. Now, I I want to fill out this graph right here. So I'm going to go sine. What's the amplitude from the midline? It's still up 10, down 10. So we got 10 because it goes up 10. All right. And then we have K is 2. So 2 theta and C is negative pi half minus pi over 2. So there's our equation right there. All right. There's our equation right there. Now, right here it says, what is the period formula for secant and cosecant? Cool. That is still the period equals 2 pi over K. Right here, what quadrants on a unit circle are positive ratios of tangent found? All right, so tangent positively is found in the first and third. And think about it, right? So if you have sine over cosine, tangent sine over cosine. Alright. Well, over here, everything's positive. So positive sine over positive cosine is positive. Right? Right here, everything is negative. So negative sine over negative cosine is still a positive. So first and third quadrant. Alright, it says using your answers of number 4, which two angles will solve to give you a tangent theta of negative radical 3. Alright, so if we have, first of all, we know that first and third are positive, but this is a negative tangent, so it won't be in the first and third quadrant. So now we need to address how do you get a, oh man, look, I'm running low on storage. We'll deal with that later. Alright, whoa, guess not. Alright, we'll deal with that later. It says using your answers to number 4, what two angles are? I read that. So yeah, back to this. This is a negative, so tangent's negative. So we won't be looking at the first and third quadrant. We're definitely going to look at the second, all right, and fourth, because tangent's negative in those two quadrants. Now, to get this, all right, remember you have to have negative radical 3 over 1. All right. And so, with that being said, for this to be in the numerator, you have to have this point right here to where your sine, all right, your sine value is radical 3 over 2. All right, so over here, the cosine is negative. Down here, all right, your sine value is still radical 3 over 2, but it's negative in the fourth quadrant. All right, so these two values right here, these two angles right here. So which angles are these? Well, in terms of radians, this one over here is going to be 2 pi over 3. All right, 2 pi over 3, or you know that as 120 degrees, or down here, we'd have 5 pi over 3. All right, and we will say that is, let's see, and this is 300 degrees, okay? Now, right here it says name an angle on the unit circle that uses a reference angle of 30 degrees. So first of all, we need to reference what is the reference angle. Or excuse me, we need to discuss what a reference angle is. The reference angle, guys, is basically the distance from the x-axis. All right, so this right here is pi, or 180, and this here. Let me use another sheet of paper real quick. Let me find the bottom. Here we go. If you have a unit circle, and this is 180 or pi, and this is 0 degrees or 0 radians, all right, or even 360. All right, we got to find the reference angle, and here's how you do it. All right, let's say I had 45 degrees right here. Well, the reference angle, guys, the reference angle is the distance from the closest x-axis to that angle. All right, so for this case, what is the distance from 0 to 45? Well, it's 45 degrees. So the reference angle for 45 degrees would be 45. But let's jump over here to, let's say, 120. All right, or what was it, 2 pi over 3? All right, well, this angle right here has a reference angle as well. This is the closest x-axis to it. All right, this side, not this side. I'm not going to look at a reference angle all over here. All right, I'm going to look at the closest x-axis. What is the distance? Well, the distance right here from 180, I would subtract, which is 60 degrees. So I would say that the distance here, the reference angle here would be 60 degrees. All right, over over here, if I did this quadrant, and let's say I said 245. All right. And what would be the reference angle then? All right. So I would do the same thing, except this time I'll subtract 245 minus 180 because this is the closest x-axis. All right, not the y-axis. These are y-axis. This is y. This is x. All right. So what would be the distance right here? All right. We say 65 degrees. 65 degrees. So even right here. Now right here you got to be mindful. Let's say I said 300 degrees. All right. You would go, what's the reference angle right here? But notice it's not 0 this time. I've already made it all the way around, so 360 is what I would look at. So what would be the distance right here? It would be 60 degrees. So the reference angle right here would be 60. Okay? All right. Hopefully I cleared that up. So let's go back to the problem that we were working. And it says, name an angle on a unit circle that uses a reference angle of 30 degrees. All right, so let's see. For 30 degrees, you will have literally 30 degrees because that's in the first quadrant. That's right there, 30 degrees. All right, what about another? All right, another reference angle that could have it. If I go over here and have a reference angle of 30 degrees, I could say 5 power to 6 would be 30, 60, 90, 50. Say 150. Alright. If I went to the fourth quadrant, I could say 7 power to 6, which is 210. That would have a reference angle of 30 degrees. And also, if I went all the way around to the fourth quadrant, 210 is down there. If I came all the way over here with 330. Alright, I can say 330. Because from 330 to 60 degrees. 330 to 60 degrees is 30 degrees as well. So all those angles have a reference angle of 30 degrees. Now, the question says, what is the tangent? All right, what is the tangent? Well, what is the... Oh, I'm on the wrong line. Sorry about that, guys. Let me fix this. Now, again, what is the reference angle of 60 degrees? All right, well, if you think about it, 60 degrees is going to be its own reference angle, and then you have in the second quadrant 120 degrees. In the third quadrant, you're going to have 240 degrees, and also in the fourth quadrant, you're going to have 300 degrees. And then 45 degrees is, of course, 45 degrees, 135, 225, and lastly, 315. All right. Now, for this next one, it says, what is the angle restriction for the inverse function of sine? Well, remember, sine can only exist on this right half. Okay, so we have pi halves up here, and we have negative pi halves down here, because remember, we only use from 0 to pi halves and 0 to negative pi halves. We do not use, it doesn't go all the way around to include the larger angles. Okay, so sine, what would we say then? From negative pi half to pi half. Oops, that's a bracket because it's included. Sorry about that. I'm going to rewrite that anyway. Tangent is the same as sine inverse. It is just only on the right half of the graph. So negative pi halves to pi halves. And then cosine, if you remember, cosine exists up here. So we say from 0 to 180. Alright, or 0 to pi, because it's in radians. So 0 to pi. Boom. There we go. Now, given the point negative 5, 8 on the terminal side of the angle, find all 6 trig functions. Cool. So we have this point right here, negative 5, 8. So let's sketch. All right, let's sketch us a graph real quick. I'm gonna make this bigger so I can have more space to write. All right. So negative 5, 8, which which means that point, -5 up 8. So there's our point right there. So there's our triangle right there. Which means, if you remember, guys, theta always comes out the origin. So now what we're going to do is use Pythagorean theorem. All right, we have 8 up 8, -5. So we have 8 squared plus -5 squared equals c squared. So that is 40. Ooh, holy moly, I did 8 times 5. That's 64 plus 25 equals c squared. When we add that together, we get 89 equals c squared. And then what is the square root of 89 going to be? Yeah, square root of 89. So square root c equals square root of 80. Alright, so now that we have that, guys, we can actually find all the other, or we can find all 6 trig functions, okay? If you remember, sine, guys, sine is opposite over hypotenuse. So sine is going to be 8 over square root of 89, which we have to rationalize. We can't leave the radical in the denominator. So we move it to the top and keep the number from the radical at the bottom. If there was a number down here, like 2, we would multiply those. Alright. I know you know that though, so. Cosine. Cosine is adjacent over hypotenuse, which equals -5 over square root of 89, which we can rationalize like that. Ooh, I almost put 80. Tangent equals opposite over adjacent, which equals 8 over -5. Now, still using the same triangle, we're going to find the other trig identities. Or you could look at your originals right here and just find the inverse. So cosecant is hypotenuse over adjacent. So I'm just going to flip this original to have square root of 89 over 8. Secant is hypotenuse over adjacent. Opposite, I don't know how I put that there, over adjacent. Which again, we can flip the original to have square root of 89 over -5. And cotangent is adjacent over opposite, which we can flip that. -5 over 8. Alright. Let's keep it going. Number 9 here says, given the radius of the circle 3.6 centimeters long, find the measure of the arc subtended by an angle of 82 degrees. So, first of all, we've got to find the radian. Alright, of this degree. So we take 82 and we're going to multiply by pi over 180. And doing so, we get 82 pi over 180, which reduces to 41 pi over 90 radians. Now, remember we use the equation r times theta equals the arc. Alright. Well, we know what the radian is. Alright. And we know what theta is. Alright. We know what r is, we know what theta is. So if we go r, right, let's say the radius right here, 3.6. So we go 3.6 times 41 pi over 90. We'll get our arc. So you can punch that in your calculator, guys, and you get 5.15 centimeters. And this is our arc. If the arc length is 6 inches, so this time we have the arc length and we have the angle of 12 degrees, we gotta find the radius. Okay, find the radius. First of all, again, we need to convert that 12. Alright, so into a radius of 12 times pi over 180. Alright, reduces, and it gives us pi over 15. So again, r times theta equals the arc. Alright, so this time we know what the arc is. It's 6. Alright, we know what theta is. And we gotta find r. So now, how would I solve this? Well, this is multiplication. So if I divide by pi over 15 or multiply by its inverse on the other side, meaning r equals 6 times 15 over pi, like that. Alright, we can solve this. And we're going to get a whopping 28.6 inches. That is the radius.
That probably take him.
Okay. Alright, number 11. On the unit circle, the ratios in the ordered pair represents the sine and cosine function. Knowing this, what would be the ordered pair for angle 3 pi over 5? Alright, so first of all, 3 pi over 5 equals theta. Alright. Now, we need to find, remember ordered pair are cosine of theta, sine of theta, right? It's always cosine sine. So if I go cosine of our theta, comma sine of our theta, I will get our ordered pair. So when I do cosine of 3 pi over 5, I get negative 0.3, right? And if I do sine of 3 pi over 5, I get 0.95. There's our ordered pair right there. Alright, number 12. Given cosine is 6 over 7 and the angle terminates in quadrant 4, what is the other 5 trig function? Alright, this is exactly like problem 8 when we did it. Alright, we know this one is in quadrant 4. Alright, there's theta. So look, listen, cosine is adjacent over hypotenuse. So adjacent would be 6. That's 7. We're going to use Pythagorean theorem to find this. Okay. So if I go a squared plus b squared c squared, so a squared, alright, equals c squared minus b squared. So 49 minus 36 is 13. Alright, equals the square root, or a equals the square root of 13. Now, I know what you're thinking, alright? You're thinking plus or minus. Why plus or minus? Well, we need the minus because this is a negative. It goes down. So sine is negative in the fourth quadrant. Now, to find the other 5 trig functions, alright? Sine equals negative 13, square root of 13, excuse me, over 7. Cosine, we already have it. Tangent equals negative square root of 13 over 6. Cosecant, flip this. So negative 7 radical 13 over 13. Oh, when you flip it, you got to rationalize it. So move the radical to the top. Secant, if you flip this, it's 7 over 6.
That probably take him.
And cotangent is -6 over radical 13. But again, you got to rationalize that. So -6 radical 13 over 13. Alright. Hey, you got a new subscriber. How cool is that? Hey, yo, if tangent is 7 over 24 and cosine is greater than 0, what other values of the file tree identity? Alright, same type of problem. So, look, listen, you know how tangent is sine over cosine? Alright, sine over cosine, but cosine is greater than 0, which means cosine is positive. So that's the first quadrant. So you have tangent opposite over adjacent. And again, we got to find or use Pythagorean theorem. Alright, so we're going to go a squared plus b squared is c squared. 625 squared is 625 is 25. Alright, Pythagorean theorem. That'll get you your little triangle right here. Anyway, now we know tangent, so let's go sine. Sine is 7 over 25. We know, oh no, we don't. Cosine is 7 over 24. Whoa. Ha! Hey, actually, I made a mistake. I just made a mistake. No, I didn't. I'm good. Cosine, I made a mistake on cosine. Sorry about that. Cosine is 24 over 25. I know you caught it though. He was like, man, that ain't right. Good job. Kudos. Cosecant is 25 over 7. Secant is 25 over 24. And cotangent is 24 over 7. Alright, man, find the component form and magnitude, alright, of the vector form from the terminal point 27 and the terminal point 46. Alright, so remember, guys, to find the vector, we gotta do x2 minus x1, y2 minus y1. So x2 would be 4, x1 would be 2. Oh, why am I putting a comma? 4 minus 2. And then y2 would be -6. Y1 would be 7. Oh, I did it again. -6 minus 7. So now we do that, and we get our vector. 4 minus 2 is 2, and -13. There's our vector. Okay, this is our vector v. So I'm going to call this v. Vector v. Now, it says find the magnitude. Well, to find the magnitude of vector v, we would say it is the square root of v1 plus, or v1 squared plus v2 squared. So that gives me 4 plus 169, which equals 173, which is approximately 13.15. There's our magnitude right there. So we found the vector, we found the magnitude. There it is. Alright, a plane is flying at a speed of 550 miles per hour heading 35 degrees east. Alright, the wind is blowing 70 miles per hour going due west. What is the actual speed and direction of the plane? Alright, so a couple things we gotta do. We're flying due east, or we're moving 550 miles an hour, heading south 35 degrees. So here's what we gotta do. So listen, we're moving at a speed of 550 miles per hour, heading south at an angle of 35 degrees east. So this is south right here, right? And we're heading in an angle of 35 degrees east. Then remember, this is 270. So 270 plus 35 is going to be 305. So we're traveling 35 degrees. All right, so southeast at an angle of 35 degrees. Now, what we gotta do is, that's all we got, 305, right? So 270 plus 35 is 305. Alright. So now we need to make our vector. So we have the magnitude times, remember we gotta find cosine of 35. I mean of 305, sorry. Sine of 305. Alright. So when we do that, 500 times cosine of 305. Alright, use your calculator, guys. That's going to be 315.47. And 500 times sine of 305 is going to be negative 450.53. And then we got to do this other side. The wind is blowing 70 miles per hour, going due west. So due west, the wind's blowing that way. Alright, and it's blowing that way 70 miles per hour. Alright. That's 180 degrees. So we gotta do 180 times, oh not 180, but the speed of 70. Sorry about that. 70 times the cosine of 180. Sine of 180. Like that. And so we end up with negative 70 and 0. Alright, so now what do we do with these two resultants right here? We gotta add them. Alright, we gotta add these. And when we add them, we get 245.47, comma, negative 450. Alright. So now we use this resultant. This is our resultant. And we're going to first find our angle by doing, remember, we do tangent inverse of y over x. And in doing so, we end up with 289. Nope, 298. Sorry, guys. 298.6 degrees. And then we got to take the magnitude to find the speed. Alright, so if I take the magnitude of this resulting vector, we'll call it vector u. Alright, we end up with 245.47 squared plus negative 450.53 squared. And when we do that, we get 513.06. So here's the angle, here's the speed.